Welcome back to the Foundation in C# course. We're currently in Module 2, and this lesson, we're going to learn all about basic variables. This is going to be the start of our learning of variables. Remember I said before that I'll only teach you what you need to know when you need to know it. So we won't cover every variable that's possible because of the fact that some you're just not going to need for a while. So let's jump right into code. So here I have Visual Studio. I'm going to go to Create New Project, Console Application.NET Framework. And let's choose a name. We'll give it Console UI as the name. And the solution name we'll call Module 2, say 02. And this is Lesson 02. So once that loads up, we have our console application. Remember, the first thing you do is at the bottom, add our console.readline. Now, what we're going to learn about is variables. And the job of a variable is to hold information for us. And that's really all it does. So let's look at a variable first, and then we can look at the different parts of it and see how it works. So let's call this variable first name, and we'll set it equal to an empty string to begin with. So this is a variable declaration, and it's an initial assignment. So we're declaring a string variable. The string is the type. We're giving it a name. That can be any name we choose within some limitations. We can't use special characters, no spaces, those kind of things. So type, the name we give it, and then if we want to give it an initial value, in this case I'm giving it 2 double quotes, which essentially is a blank string, a string with nothing inside of it. These double quotes indicate that it's a string though. Now a string variable is our most common type of variable because it's easy. Pretty much you can put anything you want into a string variable. So if I were to say first name equals, I could put letters, uppercase and lowercase. I could put spaces. I can put numbers. I can put special characters. All these can go inside of a string. Now don't forget to put the semicolon at the end. That's what's yelling about right there, that red squiggly. So this is a valid string as long as it's inside these double quotes. Now there are a few things that you need to look out for. The biggest one is if you have the slash key. This can cause problems in your code because it escapes out certain characters. So I can actually put a double quote here because you've got the slash and it says, okay, I'm actually escaping this next thing, which is the double quote, which allows me to make a double quote inside of my text. So the actual text being stored is this text right here. So that slash isn't stored, it's technically an escape character. So that's just something to be careful of when you're storing strings, is to make sure you're not using that slash character and then thinking it's going to be stored in the string. You have to do 2 slashes in order to store 1 slash in the string. And we can look at this in action. So let's do this. Let's do a CW tab, so console write line. You could type this whole thing out, or you could do that CW tab for this snippet. And then in here, instead of putting something in quotes like this, we're going to do instead without the quotes. We're going to put in first name. And that uses this variable, takes the value that's inside the variable, which is this right now, and it's going to use that in its place. So if I were to run this, and it's going to start off screen, but I'll bring it over. There we go. There's our string that we passed in. Notice there's no double quotes because those double quotes are not a part of the string. They are surrounding the string. Oops. So let's go ahead and hit stop on that. I could hit enter as well. Let's just show off, though, that the slash character, if it's in there, it will not show up. Notice how it says it's just esting, because the slash T is actually a tab. So the T represents a tab. And so it did tab, and then it did the rest of the string. So that's why be careful of those slashes in a variable. But never fear, there's things you can do. One, if you want to say, you know what, I want everything inside a string to be treated as if it's a real character, not an escape character. For example, maybe you have, and this is a good example, maybe you have this. That's a path, not .com. How about .txt? There we go. So there's a file path. But notice it says, no, I don't know what that is, because capital T isn't a representation of something if you escape it. One way to solve this would be do / so that the slash escapes another slash. Curly brace, space, last name, and curly brace. So what this does, the string interpolation says, instead of putting an actual text value here, take the value from whatever inside these curly braces, in this case, first name, so take the first name value, Tim, and it will put it in place of this. Think of it like a placeholder. So it puts Tim here. We got a space then, and then it is the last name, so Corey. So first name will end up being Tim space Corey. Let's just look at that on our console. There you go, Tim space Corey. So that's the newer way of adding strings together. So a string is just anything essentially inside double quotes. We do have to look out for that slash character, but we can use the @ symbol in order to allow us to use what would normally be an escape character to actually have it be the character itself instead, the actual literal character, slash. And if we want to add strings together or put strings inside other strings, then we can use the string interpolation, which is the $ in front of the double quotes, which allows us to put in things like the curly braces and then put code, and it puts it right in the string. Okay, so that's a string variable. It's the one that we use a lot. But there are other variable types. So let's leave all this here. And we'll come down here. Let's look at another variable type, and this one is called int. So int is a whole number. So let's make it h. And we'll start off, initialize it at 0. That's a pretty standard initial value. In fact, if I didn't give it an initial value, it would still be 0. But I much prefer to see an initial value assigned rather than having it be implied. Because sometimes when you imply something, you get confused as to what it really is. For example, string. A string's initial value is not this 2 double quotes. It's actually the equivalent of string.empty, which is different. It's not quite null. It's not quite this value right here. It's string.empty. That can be a bit confusing to work with, so I prefer to see my strings be an empty string to start. So with int, this can be any whole number, which means age equals 10, that's fine. Age equals 20, that's fine too. Well, if I put a semicolon at the end. Age equals 23.5. That is not valid because it's not a whole number. This decimal point means a fraction of a number. Can't have that in int. It has to be a whole number. Now it can be a negative number. That's fine. Now here's a real quick tip. We're not going to need it right now, but if you ever come across something that says an unsigned integer or an unsigned int, and you go, wait, what is that? This is a sign, the negative sign. So an unsigned integer means it can only be positive. It can never be negative. That's the only difference. So we're not going to need it. It's not something we often use, but just in case you come across that in your reading somewhere, that's what an unsigned integer is. So that's the age variable. Now, I want to point this out because we haven't really covered it too much yet, but the naming that I have here, first name, age. If you notice a pattern emerging, what I'm doing is it's called camel case. And the idea behind camel case, and it's what we use for all of our variables, is that the first word is all lowercase. And every word after that, the first letter is capitalized. So first name, the N is capitalized. Last name, the N is capitalized. Age only has one word, therefore it's all lowercase. And there are some reasons for this. First of all, it allows us to easily identify this is a variable. Second of all, it doesn't step on toes. Because don't forget, C# is a case-sensitive language, meaning first name with a lowercase f is not the same thing as first name. These two are different, even though they're spelled the same, because of the capital F at the beginning of the second one. Now, it's not a valid, I hate to say it's invalid name. It really isn't. But that's a convention, not a requirement. Now, most of the industry follows that convention. So my recommendation for best practices is to follow them unless you have a really good reason not to. Don't be afraid to go against them, but your default should be that you follow best practices unless you have a reason that's a compelling reason not to. When you bring new programmers on to your staff, you want them on the same playbook as you. When you go to a company, you don't want to have to change your entire way you do things then, after you've done it for years in a certain way. So if you follow the industry standard best practices, it's more likely that you will conform to others' coding standards and that others will conform to yours. It just reduces friction. So, camel case, which is lowercase first word, then the uppercase first letter of every word after that. That casing system also allows it to very easily read even long names. Okay, so let's go back to our variables. We have string, we have int. Int is a whole number. Let's look at another one. A double holds a number that includes a decimal point. Average words per minute. And that's a long variable name, but it's very descriptive. That's a valid double. Notice that it has a fraction of a number. So 34.24. Now, I immediately want to show you another type of number that holds a fractional number, and that's decimal. Cost per container equals 43.85, and it yells at me. And it says, you can't put a double in that. Well, you have to put a capital M afterwards to indicate it's actually a decimal type. So these two, double and decimal, look almost exactly the same. The only difference is you have to put a capital M after a declaration like this. And the reason why is because it thinks that this 43.85 is a double unless you tell it, no, it's actually a decimal. So why do we have two different variable types to hold what essentially looks like the same number? And the reason why is because of precision. The double is precise only to a certain decimal point. And it depends on how many calculations you've done and so on and so forth. But it's over 14. I think it's 17, 16, 17, somewhere around there, points after the decimal that it's precise to. Whereas the decimal type is much more precise. So why wouldn't we always use the more precise one? And the reason's quite simple. It's expensive. It's much more difficult to store a decimal in memory. It takes up a lot more space, which also makes it harder to work with. It takes up much more processing power to calculate decimals. Therefore, what we do is for any number that is not relating to money that needs a decimal point, we store it in a double. So that's your default. Store a number in a double if it needs that decimal point. However, if you're dealing with money, always use the type decimal. So see the difference? So, use decimal for money. And up here, use double for all numbers that include fractions except for money. Now, these are comments, just to remind you. These double slashes allow us to put text in here that describes what's going on that is not compiled. So that just kind of reminds you double versus decimal. So we have ints for whole numbers. We have double for all numbers that include fractionals, like anything with a decimal point, except for things that need money, in which case that's a type decimal. And the last type I want to look at today is the Boolean. So B-O-O-L. Let's start with false. Okay, so a Boolean stores only true or false. So bool is alive, and the value can be false or it can be true, and that's it. And a Boolean is used when we want to know if something's true or false. We use true or false a lot in programming. It doesn't seem like it's a very valuable For example, I've seen people try to force in here a gender. So, for example, they would say, is female. Well, that really doesn't tell you everything you need to know about gender. Unless you're saying we only want to know about females, you're kind of limiting yourself there because we have non-binary gender options. So therefore, it'd be is female or everything else, or is male and everything else. So don't force something into a Boolean that really isn't a Boolean. And that's true for all of these. So for age, I use age as an example a lot, and it works as a whole number. But you can't allow a 3-year-old to tell you what their age is, because they will not give you a whole number. They'll say, I'm 3.5. I'm 3.25. I'm 3 3/4. I'm almost 4. First name, last name, type of car, and then you have a variable called age. Is that the age of the person or the age of the car? That's where age of vehicle is more clear, age of person is more clear. But if you have first name and last name, your store notes kind of together, and you have age, it's implied that it's the age of the person. Now that brings us up to a tip that I want to point out and stress. Plan out the type of data you need before you create the variable. Let me demonstrate what I mean by this, but keep this in mind. Plan out the type of data you need before you create the variable. Let's talk about a variable called zip code. Now, let's start off with what people normally do when they first start learning programming, is they say int zip code. Because in the US, a zip code can be like this. And that works. So you look at that and go, great, I have a number. Zip code is a number, therefore it can go into an int because it's not a decimal point number. Another one is phone number. But here's the problems. A couple problems. First of all, if I were to write this out to the console, now let's comment out the full name. So it'll just be the console for the zip code. Now I'm going to run this. There you go. Which I want to point something out. Console write line lets us cheat. And while it's great and I love it, I do want to point out that it's cheating. We're not putting a string in here, we're putting an integer. But console write line allows us to do that. It allows us to put a lot of different variable types into these parentheses, and it still takes it. What it's essentially doing behind the scenes is if you hit dot after your zip code, these are built-in things in C#, and one of them that every object has is toString. And what toString does is it converts basically anything over to a string. In this case, it's essentially putting double quotes around it. That way it can be used by something that needs a string. Other objects convert differently, but the simple objects like we're dealing with now convert over pretty much directly. So I just want to point that out because it's not always obvious that this is true. But I want to make sure that you realize what's happening behind the scenes. Now, this zip code worked, and you're saying, hooray, maybe that's your zip code. I don't know, it's not mine. But here's the issue. There's a zip code, and I believe it's in New Jersey, and I'm not going to get it exactly right, but that's not the point. There's a zip code in New Jersey that starts off with a 0. That would be a valid zip code. I'm not sure about the 411. I know it's 08 to start with, though. So this is a valid zip code. Well, let's run this in console and see what we get. Notice the difference? It's subtle, but it's there. 08411 has now become 8411. Why is that? Well, a number doesn't store a leading 0. Because leading zeros don't really apply to numbers. So now you have a problem. And what do? Well, you need to solve it. And the way I really solve it is to do this. String zip code. And you may think, man, but they're numbers. And it's like, yes, they contain digits. That doesn't mean it's a number. It's a slight difference. So now, if I run this, notice it says 08411 because it stores every character and treats them as just another character to display or store. And just in case you're wondering, yes, there's a zip code that actually has 2 leading zeros. It's in, I believe it's in New York, and it's only for a certain mail center. A certain mail center has its own zip code, but it starts off with 2 zeros. But that is going to show that edge cases can sometimes cause you problems. And so therefore you have to think about the data that's going into your variable before you use it, before you do it. Because the opposite is also true. You don't want to store a number as a string. It just doesn't work that well. For example, what if we had age, which, let's change age one more time. Let's create new ones because you know what? New variables, new practice is always good. So let's create a variable Now I have to take the quotes off because they're not strings, they're ints. Now this would work. And in fact, if I were to run this, it says 400, meaning I've eaten, or I have 400 apples left. So we don't want to store everything on a string, which would seem like the easiest solution. But because then subtraction, addition, multiplication doesn't work with numbers, and a lot of other things as well. So we need to choose the right variable for what we're going to do, but we have to be very careful in cases like zip code and others that we differentiate between digits and a number. These are just digits, meaning, yes, they are numbers as in 0, 1, 2, 3, but they're not used collectively as an actual number. Now, in theory, in this case, you could still treat it as a number. And then whenever you displayed it anywhere, you could say, well, if it's not 5 characters long, then put zeros at the front. But here's the problem you run into. The +4. In the US, we have the idea of an additional 4 numbers after a dash in the zip code. First of all, that dash, that's not going to go into a number. And in fact, if you took the quotes off, it would subtract 4125 from 00411 and get a negative number. So the +4 causes problems, but then it also causes the problem of use the @ symbol in front of a string in order to allow you to put something in there. So for example, let's just create one more variable. File name. And file name equals, let's do the @ symbol. Okay, so that allows us to put in these escape characters without them actually being used as escape characters. This is for string literals. The $sign is for string interpolation, which is a fancy word for what this is doing, which is just replacing things inside curly braces with their text equivalent. So it says giving the text out of first name, put that in this place. So that is the string. We also have int, which is whole numbers. We have double, which is for numbers that contain fractions as long as they're not about money. Then we have decimal for those items that are about money. And we have Boolean, which stores only true or false. Those are the 5 basic variable types you should know to get started in C#. And that's really it for this lesson. Now, just so you're aware, it seems like there's a lot of code here that doesn't really do a whole lot. And you may be thinking, well, it's not really a real application. It is. It's just that we're not trying to build something that works. We're trying to build something to test out what we're learning. And these applications that you build to test out what you're learning are very important. you should definitely be creating these type of applications to learn the various things or to test the various things you're learning. I recommend that you create 3 to 5 sample projects for everything you learn. You're going to hear me say that a lot. 3 to 5 sample projects. So for this, I would create 3 projects at least, if not 5, where you're just creating variables and trying different things out. You don't have to make it work. If you want to see something, you can use the console write line and put the variable inside of it to see the value. But you're just trying to get your hands around the idea of how variables work, how to create them, how to initialize. So 3 to 5 projects for everything you learn. Just try it out. Trust me. This will give you a much better foundation than just watching. Okay, and that brings us to our homework for you. The homework is to create a console application that has variables to hold a person's name, their age, and if they're alive, and their phone number. So some old tricky things in there, like the phone number, if they're alive, their age, and then how you store their name. Okay? So I want you to create those variables. Don't stress out over it. Don't overthink it. Really, we've done most of that work already in this lesson. But create that so at least you've done it once. But like I said, 3 to 5 times is what I recommend, but at least do the homework. Okay? So that's it for this lesson. Once you have that done, and not until then go on to the next lesson.